Hello students! Welcome to today's lesson on how formulae relate back to equations, expressions, and identities, and how we can change and rearrange them. Our plan for today's lesson is as follows. We'll start by recalling our previous lessons where we discussed equations, expressions, and identities. We'll then introduce new vocabulary, formulae. Then we are going to identify and manipulate variables and unknowns in formulae with some examples. Finally, we are going to practice changing the subject of a formula in order to solve for different variables. By the end of the lesson, you'll have a stronger grasp of how to handle formulae, rearrange them, and solve for unknowns, making algebraic problems much easier to tackle. So let's get started and dive into the lesson. First, let's refresh our memory on some key concepts. Expressions are combinations of numbers, variables, and mathematical operations, but they do not have an equal sign. For example, 3x plus 2 is an expression. Equations are mathematical statements showing that two expressions are equal. For example, 3x plus 2 equals 11 is an equation. Identities are equations that are true for all values of the variables involved. For instance, a plus b is always equal to b plus a is an identity. Now we introduce formulae. A formula is a special type of equation that shows a relationship between different variables. Formulae are very useful in mathematics and science because they allow us to calculate unknown values when certain other values are known. For example, the formula for the area of a triangle is half multiplied by a multiplied by b multiplied by sine c, where a and b are the lengths of two sides and c is the included angle. Next, let's work through an example using the sine rule, which is a formula used in trigonometry. A over sine A equals B over sine B. Suppose we know the following values. A equals 2, sine A equals a half, and sine B equals the root of 3 over 2. We need to find the value of B. To do this, we will rearrange the formula to solve for B. Here's the step-by-step process. Step 1. Start with the original formula. A over sine A equals B over sine B. Step 2. Substitute the known values into the formula. 2 over a half equals over the root of 3 over 2. Step 3. Simplify the left-hand side. 2 over a half equals to 2 multiplied by 2, which equals 4. Step 4. Now we have 4 equals B over the root of 3 over 2. Step 5. To isolate B, multiply both sides of the equation by the root of 3 over 2. B equals 4 multiplied by the root of 3 over 2. Step 6. Simplify the right-hand side. B equals 4 root 3 over 2, which is equivalent to 2 root 3. So B equals 2 root 3. This example shows how we can change the subject of a formula to solve for an unknown variable. The subject of a formula is the variable we are solving for, which is placed on the left side of the equation. In our example, we change the subject of the formula to B. We need to understand why formulae are useful. They allow us to generalize mathematical relationships. They enable us to calculate unknown values efficiently. They can be applied to a wide range of problems in different contexts. When working with formulae, it's crucial to identify and manipulate variables and unknowns correctly. This involves substituting known values, rearranging the formula, and solving for the unknown variable. To practice this, let's go through another example. Consider the formula for the area of a triangle, which is area equals a half AB sine C. If we know that the area equals 10, side A equals 4, and angle C equals 30 degrees, we need to find the length of side B. Here's the process. Step 1. Start with the formula. Area equals a half AB sine C. Step 2. Substitute the known values. 10 equals half multiplied by 4 multiplied by b multiplied by sine 30. Step 3. Simplify the right-hand side. 10 equals 2 multiplied by b multiplied by a half, since sine 30 equals a half. Step 4. This simplifies to 10 equals b. Therefore, b equals 10. Great! Now let's tackle some problems to solidify our understanding of how to use and rearrange formulae. We'll start with simpler cases and gradually move to more challenging ones. Consider the formula for the perimeter of a rectangle, P equals 2L plus 2W. If we know the perimeter P is 24 and the length L is 7, we need to find the width W. Step 1. Start with the original formula. P equals 2L plus 2W. Step 2. Substitute the known values. 24 equals 2 times 7 plus 2W. Step 3. Simplify the right-hand side. 24 equals 14 plus 2W. Step 4. Subtract 14 from both sides. 24 minus 14 equals to 2W, which simplifies to 10 equals 2W. Step 5. Divide both sides by 2. W equals 10 over 2, which simplifies to W equals 5. So the width W is 5. Next, let's use the formula for the area of a rectangle. Area equals length times width. If we know A equals 20 and L equals 4, we need to find W. Step 1. Start with the original formula. A equals L multiplied by W. Step 2. Substitute the known values. 20 equals 4 multiplied by W. Step 3. Divide both sides by 4. 4 equals 20 divided by 4, which simplifies to W equals 5. So the width W is 5. Now let's try a problem involving the formula for the volume of a rectangular prism, which is volume equals to the length multiplied by the width multiplied by the height. Suppose we know V equals to 60, L equals to 3, and W equals to 4. We need to find H. Step 1. Start with the original formula. V equals to L multiplied by W multiplied by H. Step 2. Substitute the known values. 60 equals to 3 multiplied by 4 multiplied by H. Step 3. Simplify the right-hand side. 60 equals to 12 multiplied by H. Step 4. Divide both sides by 12. H equals to 60 divided by 12, which simplifies to H equals to 5. So the height H is 5. Finally, let's solve a problem using the formula for the circumference of a circle. Circumference equals 2 multiplied by pi multiplied by r. Suppose we know C equals to 31.4 and need to find r. Step 1. Start with the original formula. C equals to 2 multiplied by pi multiplied by r. Step 2. Substitute the known values. 31.4 equals to 2 multiplied by pi multiplied by r. Step 3. Divide both sides by 2 times pi. R equals to 31.4 divided by 2 times pi. Step 4. Using pi equals to 3.14, this becomes R equals to 31.4 divided by 2 times 3.14, which equals to 31.4 divided by 6.28, which simplifies to R equals 5. So the radius R is 5. By working through these examples, you can see how we use known values to rearrange and solve formulae for unknown variables. Keep practicing similar problems to strengthen your understanding of these concepts. In today's lesson, we began by recalling that expressions are combinations of numbers, variables, and operations without an equal sign, while equations state that two expressions are equal. Identities, on the other hand, are equations that are true for all values of the variables involved. We then introduced formulae as a special type of equation that shows a relationship between different variables. We emphasized the importance of identifying and manipulating variables and unknowns correctly when working with formulae, as well as the process of substituting known values, rearranging the formula, and solving for the unknown variable. Overall, this understanding is crucial for tackling a range of mathematical problems effectively. Watch the rest of the GCSE Maths course at Sophos Education.